Welcome to another video. In this video, we're going to do a quick and dirty demonstration of a Stack Overflow in Linux. We are using Ubuntu 18.04.3. So that's current. It's patched. The program we're going to be using as our example is this. It's a simple one-line program. Our entry point is here at main, and we immediately call a function called go, and the parameter of the function go is the first non-command parameter on the command line. The function go does two things. It first creates a local variable, a character array of size 8, and the second thing it does is it tries to copy the data that's passed from main, from the command line, into name. Of course, there's only 8 spots in name, so as you can well imagine, we're going to have some excitement when we try to copy more than 8 characters into that array. Just going to show you, this is the command that I used to build this file, or executable. First, I've turned off stack protection. Second, I have enabled or turned on our debug symbols. And third, I have compiled it in 32-bit mode. And then, of course, the output is just overflow 1. So we can go ahead and run it and just go overflow 1 and then do AAA and then AAA. And as you can see, nothing happens. We can add another A. And now technically we're overflowing, but I'm going to say to no real problem. We will, however, hit a problem at a certain point. There we go. This is what happens. So basically, this then is param 1. It shoots up this way. And so what we're doing is we're somewhere in here, we're putting a whole bunch of A's, and you can see here, we basically allocated for 8 of those A's, and then we have, we kind of walk up and burn through all the way up, and then slowly but surely the EBP and the ret are overwritten. And so we can't return to main anymore. We return to, I'm going to say, to an address that is all A's. And so we'll see how that works now. So we'll use GDB to do that. So we're going to do GDB -Q for quiet, kind of keeps the screen clean. And then we're going to go overflow 1. Oops, 1. Perfect. Now, the first thing I'm going to do is I'm going to do a break on main. And again, so we're going to set a breakpoint that I'm going to say right about there. As soon as we hit that spot, that's when we're going to break. The reason we want to do that is if I do a disassemble main right now, excuse me, you can see that all of these addresses, they're all, well, they're not complete. All of these zeros, not the 5, all of those zeros, they sort of represent, I'm going to say virtual or unallocated address. They're offsets from the base address. And so since we don't have that base address defined yet, because the program isn't running, we don't have real addresses there. So if I go ahead now, after creating that break, which is going to hit immediately, we do run, and then command line is going to be AAAB and AAAB. We're just going to use those B as kind of placeholders for where we are in our, I'm going to say parameters or in our payload. So I've hit enter right away. You can see we're right at the beginning. We are about to do the go. Now if I go ahead and do another disassemble main, you can see now instead of all those zeros being there, we actually have what appear to be, I'm going to say, real addresses. We can see here that is in fact that call to the function go. So all of this above there, from about this LEA, all of that is sort of setting up the program. It's all of the internal housekeeping, all of that sort of stuff for the program. And then when execution gets to this line, 565, a bunch of 5s, 571, we're going to jump to this function called go at this address. And so you can see here, I have just made a note of that address. That's where our go function is. And then of course our return function, or the first line to be executed after go finishes, is this 5655556. And I've made a note of it here. So of course what we should expect to see is this ret for the ret address, the return address, is going to be that 576 address, because we're going to start go here. We're going to do all of our go functionality going down, and then as the function finishes, the stack will be unwound, and so we will walk back up, and we will end basically at the return address. The IP, the instruction pointer, will have the return address in it then, and that will be the next instruction to be executed, which is this one right here. So if we go ahead and disassemble the go function, we can do that as well. We can see it's also got a lot of things going on, but probably the important part for us is this stir copy at this address, right? And so we're going to jump from this program into this library function call, that stir copy. So what I'm going to do, I'm going to want to stop our execution immediately before that. We can sort of fast forward through all of this stuff. We do, however, want to stop right before the stir copy, and then we'll examine memory. We'll examine this stack and we'll see what we have. So I'm going to put another breakpoint. I'm going to use a star because this breakpoint is an address. So I'm going to just right click there. So as soon as we're about to do this stir copy, we're going to stop. I'm going to put a breakpoint there. So I'm just going to show you, go back a little bit. So it's right about here. As soon as we get there, we're going to stop, and then we're going to be able to look at things. So I'm going to go ahead and I'm going to continue with a C, and immediately you can see we get to that. We're on this line. We're about to do the stir copy. First thing you should see is that this is the address where our string is, and so I'm going to do X, which stands for examine, and then it's a word. I'm going to do 4 of them, and the word in hex. And then I'm going to put that address, and I'm going to click that here. So you can see this is the first AAB, and this is the second AAB. What you'll notice, and we talked about this in class, we live in Intel in a world of big endian. So we have everything effectively backwards. So this 4-1 is this A, all the way back up. The other thing we can do is we can examine our base pointer, and we can see that our base pointer is there at that address. So if we were going to examine, let's go 4WX from the EBP. That's our EBP, and you can see this is that 576. So here's our EBP right here. This 576 is the return address. And this D783 is param 1. All right. That's what it looks like. We can do X, that's ESP. And so ESP is FFD548. So you can see it's farther down here. Let's just, let's continue. No, let's step. And so we're past it, and now we should be able to do examine $EAX. And you can see in EAX is this address. So we can do an X it's 4WX should be enough. And then that. And you can see at this address is the copy of the string now. So we have one copy of the string, the original copy there, and we have the second copy there. So that's the output of stir copy. Interesting, boring, and it continues. And we just do continue, and it exits normally. We didn't see anything untoward because we didn't actually do anything from a string display perspective. What C wishes to have is it wishes to have a null terminator, not just 1 0, but 2 zeros or 2 zeros. So it would look like 0x00. And so if we would have tried to display that string, we would have had a problem, because 4-1 would have just continued with 5-7, FB, E3, and then 0-0 would have been the end. We didn't do that, so we exited normal. Alright, so now let's try and run it again and do 1, 2, 3, 4, 1, 2, 3, 4. That fills up our standard or our normal buffer, and then we can do 4 Bs, 4 Cs, 4 Ds, 4 E's, and 4 F's. So if I go ahead and start this again using that bunch of input characters, I will hit enter. This is the first breakpoint at main, so I will continue. Now I'm about to do the stir copy. Everything should be okay. I can do an examine 8WX of that, and we will see that here's the 41, there's the 8 41s, A's, 4 B's, 4 C's, 4 D's, 4 E's, 4 F's, and then nothing. Now if I go ahead and step one further, you'll probably appreciate that no longer am I going to look good. So if I do an X on EBP, so now I have 44. So if you think about what was allowed to happen, and so remember I told you way long time ago, where was it? Right here. So you can see that we're subbing and subbing some more from ESP. So we're slowly driving down the stack. And then after that call, we start driving back up the stack. But anyway, point is, the base pointer is 44. That means the return pointer is now 45. We've overwritten the first parameter with these 46s. If I go ahead and do an $ESP, we can do that, but what I want to do is, so ESP is down here. And so what I want to do is slash, and let's see, what can we do? We can do, let's do, I don't know, 64. 64WX. Sorry, I'm just thinking about that, and it's ESP. So let's think about this. So ESP, and then ESP is going to go bigger. So ESP is at the bottom. So we can look through here and we can see this is where our string started, right? And we knew our EBP was at 520. So somewhere, so we weren't right in, we might have been local var 2, right? But basically so EBP is 520, where was it? EBP is 538. So 538 is going to be this last one here, isn't that right? This one here. So this was EBP. So we were 1, 2, 3, 4. So our buffer started at local variable 4, and then we overwrote 4, 3, 2, 1. We overwrote the EBP with this, and we overwrote the return address with this 4545. And so we haven't continued yet. Our stack is completely messed up because this basically is our stack. And I'm going to say this is our stack. It was meant to stop at the 4s, right? Because that's where our EBP is. Or maybe it was meant to stop at EBP plus ret. And so of course we blew past that. But this highlighted bit is the piece of our stack. So if I continue now, and I try to run that, well, first let's do an $EIP, and we'll see what's next going to happen. And so this 5, 6, something like that, that's going to happen. So if I do a continue, and boom, you can see the very next thing that the program wants to do is wants to jump to this address as its return address, and of course there's nothing there. Instead, we overwrote this 565 55576 with 45454545. So we've successfully overwritten this return address with something that we want, with something that we control. So instead of writing a bunch of 45s to it, which is the letter D, I think it is, no, E, we could simply point to a valid memory address that had our malware or our exploit or our shellcode in there. And so we'll look at that in our malware course. But for now, that is us examining a simple Stack Overflow on Linux. Thanks for watching. In the second half of this video, we're going to basically do the same thing, except this time in Windows, showing more or less the same sort of features, functionality, but a different tool set. You can see in front, this is the same program. I added this line just to be able to see it. And sadly on this computer, it's just for demonstration. I do not have a compiler, so it's an application. In order to do this stuff, we need a debugger. So I'm going to go to the Windows Store. I'm going to search, and I'm going to look for WinDBG. And you can see there's the preview. This is the new one. We're going to go ahead and get that. I don't want to sign in. I have signed in on all of my non-demo machines. I'm going to go ahead and install this. Perfect. It's installed and I didn't have to add. Let me just go ahead and launch. I'm going to slide this down. It's a little bit different, but again, it's a lot the same. So we're going to go ahead. We're going to go to Open. We're going to launch Executable Advanced. The reason that is different, this is when you just do launch, so if you go here, it's just the executable. We actually want to have the arguments. So I'm going to go ahead first, browse, way far over there. And that's desktop, 8290, overflow Windows. And what I want to do, arguments. So I'm going to go ahead and do, so this is that whole string. So A. I'm going to try to do this, by, fours. A, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Don't care about that. Let's click OK. All right, and so now that's halted in the back, and you can see this is all halted. And so what we can do, and this is a little bit different, so we can go to disassembly. And that's not really what we want. What can we do? We can probably do break on main. And I think it's break main. It's not break. It's BP for break point. And we should be able to just do main. Right. We're going to do G for go after that breakpoint in main. So we're going to hit enter. And now we should be able to, we're going to be in a disassembly. Uh-oh. Oh, okay, good. That's overflow Windows. I thought that it overflowed already. So same idea, basically. So here we are. We're in this. So this is the beginning. So this push EBP is setting it up. We're going to do a bunch of, I'm going to say a smaller bunch, and then we're going to do that call, and you can see this, and again, it's the same idea as the Linux idea. So we're going to call this _go function. All right. And then we're going to do some adding, and then we're going to do a ret, and then we're done. So this ret is effectively the end of the program. So this is a very small program. We set it up. We set up the stack. We get stuff going. We call go. We return, and then we sort of clean up the stack, and then we're done. let's see, what can we do? So let's do this. If we go a step over one time, like is always the case, of course, when I go from one tool to another, I forget the new tool because all I can think about is the old tool. So I stopped it for a second. I restarted. I'm at the beginning. I removed all of my breakpoints. I can go here and I can see that I have no breakpoints. What I could do is I could totally go and create a breakpoint on main, and then I could run it, and then I could do a breakpoint on go, and then I could run it again, or not run, continue. But in the interest of saving time, now that we have this debugger installed, I can just do a breakpoint on go. Excuse me. So now I have a breakpoint on go, and this is the name and this is the breakpoint. And now I can just do a G for go, and I should get there. Now I'm at the first, I'm going to say first line of the go function. So now I'm pushing EBP, I'm getting my stack set up properly. So I can now go step over, and you can see I'm moving one forward, and I can do step over one more time. And you can see now I have a memory read error at 45454545. What I can do here is I can do a D, and I can look at the ESP, the stack pointer, and the stack pointer is the bottom, so everything following it up is going to go up. So if I do a DESP, what you can see is pointing at the stack right now. There's my 41414141, and then my overwrite becomes 4 2s, 4 3s, 4 4s, 4 5s, and 4 6. So now if I do a D of EBP, that's the base pointer of this function. You can see my EBP is set for 43s. So basically, these were my local variables below the base pointer and above the ESP. This is probably some sort of a stack guard or some sort of something that I'm not thinking about. Another sort of one word's worth of information between my local variable and my base pointer. And then this would be my return address. And then of course we just go on. So if I go ahead and continue, no, not continue, go, it's not going to work. Oops. And you can see security check failure. All done. We've got a stack buffer. And that's really it. So because I don't have Visual Studio installed on this computer, it's not quite as nice. All right, one last addendum. So one of the things that I thought was really awesome about WinDBG is that if you have I'm going to say the debug symbols and the debug information, and that's called the PDB file, program debug database. Then when you're debugging it in the standard Windows debugger, the source code shows up. In that earlier part of this video, you'll notice that source code didn't show up. And it puzzled me and puzzled me and puzzled me. And then I realized inside of the executable, and you'll see this as you do more binary analysis, the original build path and file name are stored inside of the executable. They're stored in a special place, and the WinDebugger knows to find that. And if those files are found in the same original location as the path stored in the executable, that's how you can unlock this fancy new stuff. So what I've done, I've moved these files into the exact same subdirectory that they were on the computer that I used to compile them. I know If you're doing this on your own computer, if you've compiled these programs for yourself on your own, then it will just work perfectly. If you move the executables to a different computer or move them to a different subdirectory, it will cease to work. Let me take a minute and show you now what it looks like. But as you can see, I've changed the subdirectory where my files are, and I've created a shortcut on my desktop to those files. So I click Enter, restart WinDBG, go to File, Launch Executable Advanced, and you can see now this is the original, a new full-on subdirectory with that same file that I used earlier. Same exact arguments, and I'm going to go ahead and click OK. Another thing that may or may not happen, and I'm going to just click this back to threads, BP, and then go. Sometimes it will say, I don't understand what's happening. This is a sort of, I'm going to say, a shortened version. You can always go to the thread, find the main thread name, and then go overflow _ Windows ! And then go. That is the full, I'm going to say, path or the full namespace of that function. But there's the new breakpoint. If we go over here, we can see that this breakpoint is set on line 5, and the function is overflow _ Windows bang or ! Go. So if I go ahead and click go instead of typing G, and this is what I was talking about. So on this side, on the right hand side, this is where the debugger is. On the, I'm going to say the left hand side, this is where the program is source code wise. And so as you can see, this looks an awful lot like the Visual Studio debugger, and that's very much on purpose. So here we are. I set a breakpoint to start right there. That's what the red is. The yellow arrow is where we are in the program. So if I go ahead and step over, I've stepped over. So now we've done the char. We've created that char name. And now this next one, we have not yet done the store copy. This next, when I do step over, that's when I have triggered the Stack Overflow. If I were to do step into, I would trace into the Windows, I'm going to say, software development library that defines what stir copy does. So I don't want to do that. It's going to get into really complicated code really quickly in the deep bowels of Windows. I'm not really interested in that. So I'm going to go ahead, click one more time, step over. And now you can see I've got the memory read address. And then if I do a DESP on the right hand side in the middle, I can click there, and you can see here, you know, there's, I'm going to say starting at the bottom. So this, of course, is the stack pointer. Stack pointer, like I showed you on that last screenshot, which I don't have on this computer. The ESP is at the bottom, and then we work up through all of the local variables, and then we hit the EBP, and then on top of the EBP is the return address, and on top of that were any function parameters that drove us or dropped us or were available to us from that function. So that means if I just do a DEBP, it's going to be, I don't know, what is it, 43. So this all here is the local variables. This is the EBP. So we've, of course, overwritten that. And this is now the return address. And then, of course, these are just more overwrites, and you can see basically here's more of the overwrites that we did, and then whatever was original. So if we go ahead and just do a go for continue, boom. We've got a stack buffer overrun, and we're done. Done like dinner. So anyway, the point of this last little addendum, I just wanted to show you that if you have the directory structure set up and you have these other files, like, so here's the source code and here's the application. Those top two are really the only we needed. But those 3 files, and in fact, I think it's only the PDB file that you really need. If you have those and they're in the same subdirectory, when you're walking through this, we can have this beautiful Visual C, you know, source code debugger visual so that we can kind of watch what we're doing. Again, we have all of the same things in addition to that. Anyway, I just wanted to show you, and now we're done.